Hello, my name is Elijah Gonzalez, and for my final, I chose to do a violent combustion reaction involving potassium chloride and sugar. It works by melting down the chloride and mixing it with a piece of candy, then it bursting into flames. I will be explaining what is happening throughout the video and go into detail at the end. I hope you enjoy, and let's get started. First off, I need to add the potassium chloride to the test tube in order for me to be able to melt it. Here, I don't add a precise amount, but rather at least more than 1 gram of it. A heat source is vital when it comes to this experiment, as it allows for proper heating of the potassium chloride in order for it to melt. It needs to be its molten form so that way it can react with the solid sugar present in the candy. Safety gloves are required in this experiment. Even though I'm using tongs here, it is very important that I protect my hands from any sparks or other hot elements from touching my skin. When the sugar reacts with the molten chlorate, it produces a strong flame that can catch or burn things on fire within a radius as it is extremely hot. The gloves I use here are made of neoprene, which aren't as flammable as most protective gloves used in experiments involving high heat or fire, so they make for a great source of protection. As mentioned previously, potassium chlorate must be in its molten state before it is able to react with solid sugar. In some cases, sulfuric acid is added as a catalyst between non-molten potassium chlorate and sugar. However, I melted it here because I didn't have sulfuric acid on me. Either way, both are viable options of doing this experiment. Lastly, the molten potassium chloride is ready to react with the sugar within the candy. I had to break the candy in half in order for it to fit in the test tube, resulting in this. At the end of the experiment, some carbon flew off the top of the test tube. This carbon was an element that didn't fully react with the potassium chlorate and is basically just a waste product from the reaction. Inside the test tube, there are two byproducts of the experiment. One byproduct is a white solid, which is potassium chloride, or KCl. The other byproduct is a sort of caramel colored film on the outskirts of the test tube, which is partially decomposed sugar. Now, let's break this down exactly why all of this happened. The potassium chlorate was melted in what's known as an endothermic process at around 629 Kelvin or 8.9 times 10 to the negative 21st joules. The molten potassium chlorate decomposes, liberating oxygen within it to make potassium perchlorate, which also takes place in an endothermic process shown by this equation. It actually takes place in two different steps. First, the potassium perchlorate forms because of the energy heating the regular potassium chlorate, mixing it with more oxygen. Then the perchlorate decomposes, allowing it for the potassium chlorate to become molten and prepared to react with the sugar. The sugar within the candy undergoes a fast oxidization period when it came in contact with the molten KClO3, forming both carbon dioxide and water, which is an example of a combustion reaction, an extremely exothermic process. The reaction I decided to do a second trial of this reaction for fun, but learned something very interesting in the process. After adding about the same amount of potassium chloride into the test tube and about the same size piece of candy, the reaction was a lot more violent and powerful than before. This leads me to believe that this experiment in particular is sort of unstable and may react in different intensities if even very minuscule amounts of chemicals added within the reaction were modified. Comparing the two, the fire seemed to last a bit longer, was a lot more violent, and had a more pinkish purple color to it from the potassium within the second trial, rather than the first trial. In the first trial, the reaction was a lot calmer and didn't have as much unusual coloring to the fire as the second trial did. There was maybe only about a zero point 0.1 or 0.15 gram difference within the experiments. Thank you all so much for your time, and I hope you enjoyed this video.